Year 11, one easy tool that we can use to help us with redox equations is determining something called an oxidation number. It's sometimes called the oxidation state, and it's a number, it's a positive or negative number that tells us something, and it's kind of like it's answering the question, if this was an ion, what will its charge be? Okay? It's pretending. It's very powerful though. So determining the oxidation number as a reactant and then as a product tells us whether a particular element has undergone oxidation or reduction. It's quite powerful. We've kind of used it earlier. So here I've got the example of zinc and our acid, H plus going to hydrogen. Our zinc started off with a 0 charge and went to a 2 plus charge. So it increased our oxidation number. We're going to start to talk about that. Our oxidation number went up, so it was an oxidation. Here, our charge on our ion was positive, and then there was no ion, so it had a neutral charge. So it went from positive 1 down to 0, so it was a reduction, okay? So the numbers I've put in red are actually the oxidation numbers that we're going to be talking about. So we've kind of been doing it, but we're going to expand on it a bit more. But we need some rules to help us out. And there's a few rules, but you'll get used to them. Okay. A substance that appears as its natural element has an oxidation number of 0. So what I mean by that, think of the metals just by themselves. Okay. We write them as copper solid, zinc solid, 0. Any molecule like O2, P4, S8, something like that, 0. Graphite, carbon solids, and diamond, carbon solid, 0 as well, okay? If you have a monatomic ion, such as sodium plus, iron 3 plus, O2 minus, or oxide, the oxidation number is just simply the charge, okay? So sodium plus, oxidation number is positive 1. Iron 3 plus, positive 3. Fluoride, negative 1. Oxide, negative 2. Okay, fluorine always has an oxidation number of negative 1. Little rule there to add in. Hydrogen always has an oxidation number of plus 1. And here's the exception, where a previous rule requires it to be negative 1. For example, hydrides. Sometimes you come across those. Sodium is 1 plus. Hydride will then be 1 minus. But every other time, they're very unusual. If you've got a problem in the HSC or an exam, just presume hydrogen is plus 1. Oxygen has an oxidation number of negative 2, unless it goes against the past rules. And here's 2 exceptions, very, very rare. F2O and hydrogen peroxide, very rarely come up. So most of the time presume oxygen has an oxidation number of negative 2. The halogens have an oxidation number of negative 1, unless an earlier rule causes them to have a different value. Very, very rare. Okay, here's the big one. If we're talking about a molecule or a polyatomic ion, the sum of the oxidation numbers of its individual elements is equal to the charge. Okay? Words. Here we go. The oxidation number of manganese in this ion here, MnO4-, which is known as permanganate, is 7 plus because the sum of their oxidation numbers I've got on the right equals their charge. The charge is negative 1 from here on the left, okay? So I set up a little algebraic expression. So negative 1 is going to equal the oxidation number of manganese plus 4 times the oxidation number of oxygen. Expanding that out, the oxidation number of oxygen is always number 2 from rule 5. So negative 1 equals manganese oxidation number plus 4 times negative 2. Which, simplify it down, manganese oxidation number minus 8 equals negative 1. So manganese oxidation number equals plus 7. Okay, we'll do some examples. All right, look at all these that we'll quickly zip through. Okay, determine the oxidation number of the following chemical species in bold. Okay, starting nice and easy. Sodium plus, it's a monatomic ion, it's just the charge. It'll help if I had it on pencil, plus 1. Chloride, monatomic ion, negative 1. Iron 2 plus, monatomic ion, 2 plus. Chlorine, okay, 0. It's a neutrally charged molecule. Okay, only containing chlorine 2. Zinc 2+, monatomic ion, 2+. Aluminium 3+ is a monatomic ion, 3+. Oxygen there, 0. Iron, 0. Sulfur, 0. Carbon 60, the old buckyball, 0. Okay, here we've got some molecules here. So sulfur dioxide, and we're going to use the rule 7. The sum of the oxidation number of an ion or molecule equals the total charge. What's the total charge? 0. Okay, sulfur dioxide is not charged. So it equals the oxidation number of sulfur plus 2 times the oxygen, which equals sulfur plus 2 times -2, which equals sulfur minus 4. Okay, add 4 to both sides. Sulfur's charge is positive 4. Okay. Sulfate, the sulfur in sulfate, the charge is -2, and it's going to equal the oxidation number of sulfur plus 4 times the oxidation number of oxygen. Expand it out. Oxidation number of oxygen is -2, so 4 times -2 is -8. Add 8 to both sides. Sulfur has an oxidation number here of +6 for sulfate. HCl, the charge is 0. Okay, I've highlighted hydrogen. Chlorine is a halogen. It's going to be from rule 6, -1. So 0 equals H minus 1. Add 1 to both sides. H equals +1. The nitrogen in nitrate. Well, the charge on nitrate's -1. Nitrogen plus 3 times the oxidation number of oxygen. So -1 equals nitrogen plus 3 times -2, which is -6. Add 6 to each side. Nitrogen has an oxidation number of +5. Phosphorus in phosphate. The charge is -3. It's going to equal oxidation number of phosphorus plus 4 times the oxidation number of oxygen. So it equals 4 times -2 is -8. So phosphorus equals +5. N2O4, the charge, it's neutral, 0. 2 times nitrogen plus 4 times oxygen. Okay, so 0 equals 2N minus 8. So N equals +4. Permanganate. Did I do that in an example? I did. Let's do it again. -1 equals manganese. Help if I could spell manganese. Plus 4 times oxygen. So -1 equals manganese minus 8. Plus 8 to both sides. Manganese, in this case, oxidation number is +7. Chromate is the next one. So -2, because that's the charge of the ion. Chromium plus 4 oxygens. -2 equals chromium minus 8. Chromium 6+. That is the very toxic chromium. Is it? Let me remember. I don't think it is. I think it's the next one. Okay. Still not good. Dichromate is the terrible one. Okay, let's solve it. So -2 equals 2 chromiums plus 7 oxygens. Okay, oxygen's -2. So -2 equals 2 chromiums minus 14. Okay, add 14 to both sides. 12 equals 2 chromiums. Chromium equals 6 positive. I thought it was just dichromate. Anyway, that'll do. May have made a mistake there, but I think it's all good. You get the picture. Okay, so now you've got enough to do the little worksheet on oxidation numbers, and we'll start to do some balancing of some harder stuff. Okay, thanks. Thanks, guys. Talk to you next time.